and thank you for accepting the request to join 30 minutes earlier. Okay, today we want to look at another type of unsupervised machine learning that is called association, and it is actually the one that mostly follows clustering. Now, in clustering, we say that we always form groups of data points based on similarities or differences, which means that when we are making clusters, we are always interested in a cluster that has data points that are of similar characteristics, and that's why we mostly touched on exclusive clustering. Now, another type is called association. Sometimes in a data set, it can be very difficult to bring together data points that have similar characteristics or similar features, but we can form an association. We can actually form a union between the data points wherever they are without necessarily forming a cluster. So this is a data mining technique, and it's a very powerful mining technique that is at the intersection of data mining and also data engineering and also machine learning. So rule mining is a rule-based approach to reveal interesting relationships between data points in large data sets. Yes, we do not necessarily need to form a cluster, but we're just going to establish relationships between these two data points. And unsupervised learning algorithms search for frequent if-then associations, also called rules, to discover correlations and co-occurrences within the data and the different connections between data objects. We are going to look at frequently occurring relationships. Then if there are frequently occurring relationships, can we then form an association or a rule between these frequently occurring relationships? And this is the reason why this technique is powerful in recommendation system. Because if it is frequently, then it means that even the new data point that is coming in, if it has similar characteristics, then the relationship can be established between that dataset and the ones that are already existing. It is commonly used to analyze retail baskets or transactional datasets to represent how often certain items are purchased together. You are familiar with the term people who purchased this also liked this. Yeah, that term was actually coined from machine learning technique of an association rule. So we are going to see the two models that are built under this. These algorithms uncover customer purchasing patterns and previously hidden relationships between products that help inform recommendation engines or other cross-selling opportunities. And like I said, you might be familiar with these rules from the frequently bought together, and people who bought this item also bought sections on your favorite online retail shop. Association rules are also often used to organize medical data sets for clinical diagnosis. Using unsupervised machine learning and association rules can help doctors identify the probability of a specific diagnosis by comparing relationships between symptoms and past patient cases. So this is an unsupervised learning technique, meaning it itself uncovers hidden patterns in the data set. And after uncovering these hidden patterns, then it tries to establish the relationship between the data points in the data set. However large it is, at the end of the day, we are going to have what is called a basket that contains items that are always related, or items that are mostly bought together in a retail basket. Principle of association rule. So there are some mathematics here, algebra to be precise. Let I be an empty set. It is not an empty set, sorry. Let I be a set of items. So the alarm that you look inside there means it's a set of items. So be a set of n binary attributes called items. Let D be a set of transaction called database. Each transaction in D has a unique transaction ID and contains a subset of items in I. Are we together up to that point? Meaning, if you have a basket of items and you bought them from market share platform, then definitely there's a transaction ID connected to each and every item that is in your basket. And this transaction ID can only, or this transaction set can only be gotten after you have I. It is not necessarily a subset of I, but it is an association of I. There is a relationship that exists between D and I. So a rule then, as a unique transaction ID and contains a subset of the items in I. A rule is defined as an implication of the form X is mapped to Y, where X, Y, given X and Y, I and X, then Y, what is Y? X is mapped to Y, and given X and Y, then I and X, what is Y? So we are going to see why all those exclamation marks and equation marks and what they mean. So the set of items X and Y are called antecedent and consequent of the rule respectively. Do not worry about the mathematical terms, you're just getting introduced to them. But the key term here is we have a set or a basket of items that you purchase from a retail or online store, or basically from just a supermarket. They keep the data. Then you have a D, which is a transaction set that is can actually be associated with I. Then we have some unknown X and Y, where X is an item, maybe an item in D, and Y is an item in I, where X can now be mapped to Y. X in D can be mapped to Y in I. I hope sijakupoteza and you are getting the concept here. Okay. And now this idea behind the association rule. In association, we identify the set of items or attributes that occur together in a table. This set of items is called an item set. When you are invited for a task in Python, they test what is called data structures and algorithms. One of the most important data structures that will always be tested will be list, collections, sets, dictionaries. That one, just know that each and every time you are going for an interview, just prepare yourself on data structures. It will never miss. They will test a list. So mostly they love using a list because you can perform like everything with the list. You can pop, you can stack, you can remove, you can add, you can do everything with the list. So they always test the list. Now, but we cannot ignore a set, and that's why we have a set here. Now, why are they using a set and not a list? You see, when in a transaction database or a retail set, goods once purchased cannot be returned unless there is a return policy, which for you to return, the company always ensures that it has gotten some profit from your money. They will take you around. Oh, we have some challenges. It will be sorted in the next week. So when they see things are now spiraling out of hand, that's when they can do the refund. So that's how exactly how a set behaves. You can only remove from a set, but you cannot pop, you cannot replace or anything. Or if it's replaced, it's going to take. So that's why we're using a set. But don't want to get more into the development part of it. Let us just look at it raw wise. A set is an item set is a basket of items that you purchase from an online retail shop. If it has k number of items, it is termed as k item set. And for it to be termed as k item set, then k must be greater than or equals to 2. I mean, basket iko na kitu kimoja, then you term it k item set. Set. No, cannot. An item set can occur frequently and thus be termed as frequent item set. And as data scientists, we are always interested in the frequent item set. Thus, frequent item set is in mining. A frequent item set mining is a data mining technique to identify the items that often occur together. A set can only be termed as a frequent item set if it satisfies a minimum threshold values, which we are going to see. When can we say that this is a frequent item set? When can I say that this is a frequent customer at market share? These values include support and confidence, which are going to see what they mean. support and confidence. These are the presentations we talked about in a frequent item set. Support shows transactions with items purchased together in a single transaction. Transactions with items purchased together in a single transaction. That is D in I, that is what at one, like it was done in a single transaction. You don't need to separate it. Oh, by the way, uh, MarketShed is an e-commerce marketplace. So what happens is that when you purchase items, there is one transaction ID when you pay, but in the back end, it is going to separate these items per order from a seller and email the seller immediately. So which means that I'm just coming to the support thing, which means that with a single transaction, the transaction with a single transaction, you can be able to see orders, different orders under a single transaction. So this is basically what support may mean in this term. When the client comes in, pays 230,000, then in the back end it is disintegrated into uh, transaction ID this, order item number 1 to the seller number 10, ID 10. That's what is meant by support. Confidence shows transactions where the items are purchased one after the other. I'm confident that this guy is gonna come back. So this is actually what confidence means. So in frequent item set mining method, we consider only those transactions which meet the minimum threshold support and confidence requirements. And one of the most common algorithms used in data mining is the frequent pattern mining (FPM). It is used to discover relationships between different items in a dataset, often represented in the form of association rules to find irregularities in the data. Now, the first algorithm we are going to look at under FPM, frequent pattern mining, is a priori algorithm. Look at where we came from. Okay, we looked at item set. We first of all introduced association rules. Then we looked at item set, and we said that association rule is actually given a set of item I and a transaction that maps to this set D. We can have a transaction X that maps to item set Y or item Y in item set I. Then we say that this item set can only, if it has k elements, it can be referred to k item set, and it must meet some minimum conditions, one of which is support. And we say support is the transactions with items purchased together in a single transaction, whereas confidence, transactions of items purchased one after the other. Then we said one of the most common algorithms used in data mining to do frequent mining, frequent pattern, to do frequent mining or association rule is called FPM. And under FPM, there are some models, which is a priori algorithm, FP growth, Exilat. There are so many, but this reading is going to focus on a priori. Oh my God, I love a priori and FP growth. You want to see, as we move with the theoretical approach to a priori, you will be like, Jesus, this is so much direct and it's so much sweet. Like, it is one of the items that actually works best with the recommendation engines. Association rule example, before we move to a priori. An association rule A maps to B will be in the form of, listen, A to B, arrow there, arrow in the middle, will be in the form of, for a set of transactions, some values of item set A determines the values of item set B under the condition in which minimum support are met. For a set of transactions, some values of item set A determines the values of item set B under the condition in which minimum support are met. What did we say about support? We said that support is actually transactions of item set in a single transaction. So it means that one might be a subset of the other. Consider a situation where there is a 2% transaction that bought bread and butter together. and there are 60% of customers who bought bread as well as butter. This can be represented in the form bread to butter, support at 2%, confidence at 60%. Yeah. Why? 2% transaction bought butter, and we do not know how many, at this point, we still do not know how many clients or customers bought bread and butter together. But when you now go ahead, and we said confidence is actually when they keep on coming one after the other. So that's why 6% of customers who bought bread as well as butter are referred to as confidence. Association rule mining consists of two steps. Find all the frequent item sets, generate association rules from the above frequent item sets. Then use this generated association rule to group the incoming clients or incoming transactions. So yeah, so anytime, yeah, ask your question. Yeah, yeah, that's exactly what is happening here. Then we have some formulas there. In mathematics, we cannot miss formulas. So the support of A is a number of transactions in which A appears, divide the total number of transactions. That is to say, support we said is a transaction in a single, uh, I mean a transaction of item set in a single transaction. So it means that we might not have single transaction as total transactions, number of transactions, but we might have n number of transactions. But this single transactions, of course, it's one. So why did we say? That's why we said that support shows transactions with items purchased together in a single transaction. So when we come to the formula, the number of transactions in which A appears. So a single, if you are going to look at the total number of transactions in your database, you want to see in this A how many. So actually, when we talk about A, we just talk about orders. How many items in the orders? Like how many items? How many orders that we have in this range of transactions had A, the item A in it, another transaction we might end up having, let's say, transaction one, this guy came in, purchased a smartphone and a casing. Transaction two, the guy came in, purchased this nini that we used to play e-football, whatever, FIFA, purchased FIFA and the phone casing. Then transaction three, he came back, purchased a cable and phone casing. So at the end of the day, the total number of transactions are three. Then in how many transactions did phone casing appear? 3/3. So support of phone casing is one. But what about FIFA? 1/3. So it's a third. So the highest, meaning the highest value of a support can only be one, and the lowest can only be zero. So support ranges from 0 to 1. Are we together up to that point? So it basically shows you the orders, and in these orders, how many transactions did we have for these orders? Then note down the value of capital N. Then you continue and ask yourself again. After now seeing that the number of transactions in this order, how many transactions did an item, let's call it item J, appear in these orders? Like in how many orders did item J appear? Then when you now want support, order with item J all over total number of order transactions. Confidence A to B. Support of A union B all over support A. We said that B is some item set altogether, while A is also an item set altogether. So when we talk about A union B, we basically say transactions that is contained in both order A and also contained in both order B. So all over support A. But what if it's confidence of B given to A? Confidence of B to A, it will be opposite. Support of B union A all over support of B. Okay, let me use paint. Not support of A given B, confidence. I think that's what it is. Confidence of A given B. Support is only for a single item. Yeah. So confidence of A, I don't want to call it given, A to B is equals to support of A union B, A union B all over support of A. Okay, let's say we have orders. So in this basket, this order contains orders from A and orders from B here. So this order has 3 item set. This order here we have case, we have charger. Here we have FIFA, we have case. Then in this other one, he came back and purchased smartphone and a laptop. Then in support, that is order A and this is B. In this one, the guy purchased case. Then remember this is a single transaction, but different orders. The same again here. This is another single transaction, again orders. So we are looking at confidence. We said confidence only comes up when we have items purchased one after the other. So this B has been purchased after A. That's when we can calculate confidence. But support is only for a single transaction. Think of it as just kujaza your cart. You just fill your cart. Then at the end of the day, you decide, let me now go to the checkout. Then you go to the cart and checkout. Then we also have case, a single one maybe. Then here he purchased another monitor. Then maybe alifanyiwa repair. Okay, so the confidence of A given B support of A union B. For us to have union, we basically say the one that appears here and also appears here. Which one is this? Is case and case and case. So support of A union B will be 3 all over. Basically anything that appears in B and at the same time appears in A, there are 3. Support of A. In A, it is 2 over 3. If you can see, 2 all over 3. So divide by 2 all over 3. So 3 times 3 all over 2, which is 4.5. So that's it. While I guess if you multiply times 100, it becomes for 50%. That's a very big confidence. But then you need, if you multiply by 100, it becomes 67%. The support. So it can be a bit confusing, but you will just do research and watch more and more videos. Advantages of frequent item set mining. Frequent item set or pattern mining is broadly used because of its wide applications in mining association rules, correlations and graph patterns, constraint that is based on frequent patterns, sequential patterns, and many other data mining tasks. So it has many applications in retail purchase pattern analysis. So it is always broadly used because of the fact that it can identify correlations and graph patterns. Like by graph, this is actually a graph per se. You are able to see how these are connected. These two are connected. That is one. Also, constant that is based on frequent patterns. The constant is basically the hindrance. The hindrance that is actually can be realized in the frequent patterns. Some of these hindrances that a guy can just be purchasing electronics items. Then one day when he comes into the site, he meets something like a perfume, then he purchases the perfume. That's totally different from what we are used to. So that's a constraint. But at the end of the day, it's still a purchase. So when you are going to make a frequent item set for this guy, you'll be like, Jesus Christ, this guy was used to electronics. Then sequential patterns and many other data mining tasks. It has many applications in retail purchase pattern analysis. Types of unsupervised learning algorithms under association. We have the a priori algorithms, ECLAT algorithms, frequent pattern growth or FP growth. And this type of algorithm will only build a priori and FP growth model. I think ECLAT is a continuation of a priori. And there is the reason why people do not like it because it tends to overfit a lot. But I guess I did some explanations down there, so you'll see. A priori algorithm. This was the first frequent item set mining technique. It uses two steps, join and prune, to reduce the search space. To prune is to remove, to join is to bring together. So searching and pruning is done on iterations. So we repeat and repeat until we are sure that this is the basket that we need with for items. What a priori algorithm holds. I'll see if this one will be the mini that we will deploy before we break. I'll see. Because I feel like it will be the one that we shall deploy since we might use the earlier market share data set to build it. So what a priori algorithm holds? The probability that item I is not frequent is if the probability that item I is not frequent is if. Let me give an example to explain. I said a guy has been coming to the site and purchasing electronic items, phone casing, chargers, FIFA. So at the end of the day, we have his basket. The frequent ones are electronic items. Then one day, when producing our site, he comes across a perfume that he likes, then purchases it. You see, this is not frequent. So the probability that this perfume is not frequent is if the probability of perfume is less than the minimum support threshold, then I is not frequent. When can you know that the probability of perfume? You just take the number of times the perfume was bought divided by the total number of orders this guy has ever made. So if it is one, if the guy has ever made 100 orders, then 1 all over 100. The minimum support threshold. The minimum support is that we say it's support is that item that frequently appears in the guy's transaction set. Support the transaction item of item set that frequently appears. So it is we do not want to the phone casing. We said it's 2/3. So 1/100 is less than 2/3. The minimum support threshold. Then perfume is not frequent. Tumeelewana hadi hapo? Aya, the probability of I plus A is less than minimum threshold, minimum support threshold, then I plus is not frequent, where A also belongs to item set. So we are adding another item apart from perfume. Let's say a shirt or a jacket. So even if you add these two probabilities, the shirt is over 1/100, the nini is 1/100, so the 2/100, which is 1/50, still less than 2/3. It means I plus A, the perfume and the shirt are not frequent. So when you are building a priori, do not include the ones that are not frequent. Because remember, our main target is to predict for someone who is coming what this guy might have been. This guy, we take the characteristics from him. Where does he stay? The age bracket and everything. Then, when someone with similar characteristics come to our site, we tend to recommend for them the items that this guy one had been purchasing, unless he also comes with a new purchasing pattern. So we may not want to predict something that may not interest the other party, or leave alone the other guy. Even this guy, when he comes to the site, next time to purchase item, maybe purchasing this shirt was just because he saw it on the site and he was enticed and decided to purchase it. Maybe. But when it comes to the site, we should always try and recommend to them what they love to buy. That's why we are doing away with things that are not frequent. If an item set has a value less than minimum support, then all of its supersets will also fall below minimum support, and that can be ignored. This property is called the anti-monotone property. The anti-monotone property is what we've been doing, removing all those the subsets that are to be ignored because they're not frequent item set. So there are two steps in a priori algorithm. The join step. This step generates k plus 1 item sets from k item sets by joining each item with itself. We are going to see how. Then prune step. This step scans the count of each item in the database. If the candidate item does not meet minimum threshold, it is regarded as infrequent and it is thus removed, anti-monotone. This step is performed to reduce the size of the candidate item sets. So when we come to implementing a priori algorithm, a priori algorithm is a sequence of steps to be followed to find the most frequent item sets in the given database. This determining technique follows the join and prune steps iteratively until the most frequent item set is achieved. Join and prune. Basically, you just remove what is. You use the anti-monotone technique to remove what is may not be required until you ensure that the frequent item set is approved. And for us to do that, we need the minimum support threshold is given in the problem or it is assumed by the user. In most cases, we always assume it. Just like when in the first case, that is in the first instance, that's like when what we are doing with k-means, the centroid was always assumed in the first instance. Consider an a priori algorithm with support threshold is equal to 50%, confidence is equal to 60%, which means that item 50% support of items I2 maybe that most frequently appears. So look at the transaction T1. The list of items purchased is I1, I2, and I3. When he came back to the site for transaction T2, he purchased I2, I3, I4. For transaction 3, he purchased I4, I5. When he came back for transaction 4, he purchased I1, I2, I4. When he came back for transaction 5, I1, I2, I3, I5. So we want to do joining and pruning until we remain with the frequent pattern. Then this is the one we will recommend for him next time when he comes back to the site before purchasing anything. Find the count of each item generally. So item 1 has 4 items, item 2 has 5. Wait, that is generally, not in per transaction, but generally we are looking at support threshold. So we say the total number of transactions. So we are looking at the total number of item appearances in the total number of transactions. So I1, I2. Yes, like generally in all the transactions, not total, but generally in all the transactions. In all the 6 transactions, correct. And item 2, 5 times. So that is step 1. Then step 2, which is the pruning step, you delete all the transactions which do not meet the minimum support. Higher. Then we say that the minimum, remember the minimum threshold is equal to support threshold times the total number of transactions. So how many transactions do we have? We have 6 transactions. Then the minimum threshold is support threshold, which is 0.5 times the total number of transactions, which is equals to 0.5 times 6, which is equals to 3. So any item that has less than 3 is removed. Yeah, so when you look at that, 2 has been removed. I5 do not meet this minimum threshold and therefore it is deleted. We carry on to the next iteration, I2, I1 for I2, 1, I2, up to I4. Find the count of each item again. Nimerudi wapi? Aya. Then join step. Form a two item set now, possible combination of items that can be purchased together based on table 1. So it's basically combination and permutation. I1, I2, I1, I3, and I1, I4. Then you start again. Now we remove I5. Then I2, I3, I2, I4, I3, I4. Then after doing that, we find the count of the combinations. How many times I1, I2 may appear. Then when you do that, they can appear 4 times. What about I1, I3? Okay, based on table 1 here. So in transaction 1, we have I1, I2, that is 1. Then in transaction 4, we have I1, I2, that is 2. Transaction 5, I1, I2, that is 3. And transaction 6, I1, I2, that is 4. That's why equal 4. So we base our arguments in table 1 even if we had removed item 5. So item 5 will not appear anyway actually. The same thing for I1, I3. After doing that, again, remove the item that do not meet the minimum threshold. So when we remove, delete item that do not meet minimum threshold. So set I1, I4, and I3, I4 do not meet, does not meet because should be do not, because minimum support is 3, therefore it is deleted. Again, we do the, yeah. 3 or the minimum support or above. The next thing is now to perform a joining 3 or more now. We now perform 3 or more. Next, we form a 3-item set. That is join and prune. You see how it is done iteratively as we go on. So again, if you now remove, you remain with only delete the non-compliant item set. When we delete all those transactions whose minimum support will not meet the threshold, we will remain with one item set I2, I1, I2, I3. And we say it is the only frequent set. So the only frequent set, which means that anytime the client comes to purchase an item, probably he might end up purchasing item 1 or item 2 or item 3. Or in most cases, they are purchased together. Then number 7, hatujamaliza, tumeanza actually, sasa maths imeanzia. Then number 7, we generate the association rules. Then the association rules could be item 1 and item 2 mapping to item 3. Then confidence is support of item 1, item 2, item 3 divided by support of item 1, item 2. Which is 3 or 4. That is the number of times item 1, item 2, and item 3 appeared, divided by the number of times item 1 and item 2 appeared. 3 over 4, which is 75. Are we together to that point? Then item 1, item 3 given item 2, the confidence is support of, that is to say, the support of everything in the question divided by the one that is being mapped, that is mapping something onto the other. So as you can see, support of item 1, item 2, item 3, all over support of item 1, item 3. The same thing with item 1 and 2 mapped to item 1, and item 1 mapped to item 2, 3. So it's just playing around with the figures. Then this shows that all the above association rules are strong if the minimum confidence threshold is 60%. Remember the confidence that we were given in the question was 60. So again, leading us to how do I determine the minimum threshold and how do I determine the confidence? Grid search CV. So you're just going to put in a value, then do a permutation until you find the best one that will generate the minimum threshold. Advantages of a priori algorithm, whatever you saw there is what we call easy to understand algorithm. And the join and prune steps are easy to implement on large item sets in large databases. I think the most easiest part to understand is here. Just pruning, joining and pruning, joining and pruning until you are done. So then the association rules which are then generated are basically to divide You just take the number of appearances from the table divided by this until you exhaust all the possibilities. Disadvantages. It requires high computation if the item sets are very large and the minimum support is kept very low. Why? Then the entire database needs to be scanned. Yes, yes, you must scan the entire database. How then can we improve a priori efficiency? Hash-based technique. This method uses a hash-based structure called a hash table for generating the k item sets and its corresponding count. It uses a hash function for generating the table. So basically, what we are saying, we are just developing a new table altogether that is not a database, but it's called a hash table, so that at the end of the day, it is used to generate the k item sets. What we just did there is called hash-based technique. Number two, transaction reduction. This method reduces the number of transactions scanning in iterations, which means that the transactions which do not contain frequent items are marked or removed. So we've done that. So partitioning. This method requires only two databases scans to mine the frequent item sets. It says that for any item to be potentially frequent in the database, it should be frequent in at least one of the partitions of the database. Do you remember what we were doing with join and prune? We were actually joining. Then after in the next part, again scan the entire database after removing. But in this one is saying you can partition, not recommended. Sampling, a random sample S from database D. So you just use the random sample of items from the database. Use, and what did we say? We said that most of the time you use the CD reproducibility of 42. Not recommended because you're not going to scan the entire database. But highly recommended if you have a very large data set with low computing power. Dynamic item set counting. This technique can add a new candidate item set at any marked start point of the database during the scanning. It can add new candidate item sets at any marked start point of the database during the scanning of the database. So it means that we keep on counting and updating. That's basically dynamic item set counting. That's what we are doing. Just update and count the number of occurrences until we've arrived at the right scenario. A priori algorithm is applied in education field, extracting association rules in determining of admitted students through characteristics and specialties. Then in medical field, for example, analysis of the patient's database. In forestry, analysis of probability and intensity of forest fire within the forest fire data. And a priori is used by many companies like Amazon in the recommender system and by Google for the autocomplete feature. Any question? Anything you did not understand? Yep. Sawa sawa. So when you hear of the word a priori, is just actually first of all you must have a minimum threshold and the confidence. So once you have these two, you now use the step of joining and pruning until you arrive at your answer. So yeah, these things are coded by people. And fortunately for us, we are going to use one that has already been coded. But one day, if you go ahead, I'm always telling myself, I may find myself doing masters in machine learning or data science and so on to PhD. So you might find yourself being employed at a company like Google developing another a priori, because the a priori algorithm was developed by someone. So Google may develop theirs and give it a new name altogether, but using the same technique. FP growth. Let's look at this because I can see still we have some time. We will build them together. I told you there were a lot of things and we had to cover them within 3 months. That's why I say I'll be like it's very difficult to condense. So frequent pattern growth or FP growth. In our last algorithm, we discussed about a priori algorithm, ways to enhance its efficiency, its advantages and disadvantages. That's so high school. Some common disadvantages we touched on include using a priori needs a generation of candidate item sets. These item sets may be large in number if the items set in the database is huge. A priori needs multiple scans of the database to check the support of each item set generated, and this leads to high costs. Frequent pattern growth is another association technique that can address all these a priori shortcomings. Let's dive deep into FP growth. Jesus Christ, did I have time to make all this? Then FP growth as an improvement of a priori algorithm. This algorithm represents the database in the form of a tree uh, called a frequent pattern tree or FP tree. Ukisikia tree, think of the decision tree where we had nodes and everything. It is coming back to haunt us here a little. A frequent pattern is generated without the need of candidate generation. So we do not need to have actually the candidate is basically the first item set generation. So the tree structure will maintain the association between the item sets. The database is fragmented using one frequent item. Then the fragmented part is called the pattern fragment. Don't worry about these terms. Like your figure out, you're going to see how it's done. Let's move on. Then the item sets of these fragmented patterns can be analyzed. Thus, with this method, the search of frequent item set is reduced comparatively. So if you compare it with the previous one, the current one has been reduced. At the heart of a P growth is a P tree. This is a tree-like structure that is made with the initial item sets of the database. It aims at mining the most frequent patterns. So as we move down the tree, we are actually reducing. We are actually just doing away with we are removing down the tree along the tree line. We are removing the ones that are not frequently purchased. Remember, yeah, sure. We remember the Apriori was doing it by pruning, joining and pruning. This is now doing it by comparing the current one and the previous one and forming a tree out of it. Each node is coming to 130 just immediately. Node. Each node of the P tree represents the item of the item set, and it actually represents an item that is remaining. The root node represents null. Yes, the root node represents null, while the lower node represents the item sets. Okay. Let's see how the association of the nodes with the lower nodes, that is, the item sets with the other item sets, are maintained while forming the tree. So FP growth steps. The FP growth method lets us find the frequent pattern without candidate generation. Let's go through the steps that are required to have a fully functional FP growth algorithm. Number one, remember we are using the same data set. Scan the database to find the occurrences of the item sets in the database. The step is the same as the first step of the Apriori algorithm. The count of one item sets in the database is called support count or frequency of one item set. One item set is basically that item. For example, I1 is 1. So that's what we mean by one item set. It means that the set of items that contains this one item. Consider a support threshold of 50 and the minimum of 60. The minimum support is 0.5 times the number of transactions. So the minimum support is 3. Minimum support is different from support threshold. The minimum support is calculated by taking the support threshold times the number of transactions. Whereas support threshold is taken by taking the number of in the total number of transactions, the number of transactions that has the item I or the item K divided by the total number of transactions. So like in this case, there were 2 transactions with phone casing divided by the total number, which were 4. So 2 over 4 became 50. percent. So step one, scan the database, then count each item. We said this is the same as the first step of the a priori. Then you delete the item that fails to meet, then sort the items in descending order. So this is where things start spiraling out of hand now. After deleting the item that fails to meet, we do not iterate now, or we do not combine. We just we just sort them in ascending order, and we start building the tree. So that this is where now a P growth and a priori separates from each other. Considering the root node null, the first set, remember it's null because first of all is when we just scanned the database. So you want to see how it's updated. The first scan, consider the root node null. The first scan of the transaction T1, which T1 had item 1, item 2, item 3, contains 3 items. Item 1, which appeared once, item 2, which appeared once, and item 3, which appeared once, where item 2 is linked as a child to root. Item 1 is linked to item 2, and item 3 is linked to item 1. To, as a child to root, item 1 is linked to item 2, and item 3 is linked to item 1. I'm going to tell you to show you why we've used item 2 and not item 1. So let's just move. Then transaction 2 contains item 2, item 3, and item 4, where item 2 is linked to root, item 3 is linked to item 2, and item 4 is linked to item 3. But this branch will share item 2 as node, as it is already used in item 1. So there's a tree down there you are going to see. Increment the count of item 2 by 1, item 3 is linked as a child to item 2, item 4 is linked as a child to item 3. It's somehow confusing, but it produces a better result than a priori. So you link similarly when you branch it so and so until you reach the last. So there's no need of reading all this if you still cannot understand. So let's look at the tree. The one is null. The resulting of tree will be like this. Aya. What we were doing, in short, you look at the database. In a series, then the reason why we sorted in descending order, we wanted to find the maximum one. So the maximum one was the one that was actually being gotten from the root null. So the maximum one must be attached to the, as the first branch of the tree, it must attach to the root node, and the maximum one is I2. So that is always the secret. Okay, in most cases, our professor used to tell us that it is a secret, yes, but the reason why we just have to go manually with scanning the database is because maybe if it doesn't work, but I've never come across a transaction set where it doesn't work. Mostly it works. After doing that, you now come back and see what is actually getting out of item 2. Again, look at the database. Item 1 and item 4 and item 3, they have the same number of items. So, and look what is getting out of item 2, item 1, item 3. Yeah. Then, but now everything is here. There is another branch of item 4 that is gotten from null na iko na moja tu, yet item 4, as you can see, had 4 items there. But if you look at this P tree, if you count the total number of occurrences of item 4, they must be 4. They should be 4 actually. Yeah. So item 4 1, item 4 1 iko wapi ingine? It should be 4. Yes. No, but yeah, you can see 3 item 4. That is 1. Okay, let's see the 3. Let me see. Okay, now the child item 2 was linked to the root as a child to root. The reason why item 2 has been linked as a child to root is because of the maximum secret that I told you of. Then item 1 is linked to item 2. And because in transaction 1, item 1, item 2, and item 3 appear together, then item 2 and item 3 must be linked to item 2. So that's what has happened there. So item 1 has been linked to item 2 and item 3 has been linked to item 4. Now we continue. Then transaction 2, item 2, item 3, item 4 contains item 2, where item 2 is linked to root. Listen very carefully. Item transaction 2, we have item 2, item 3, and item 4. But item 2 is already linked to root. And item 3 has been linked to item 2 from the previous linking in step 1. So item 4 is linked to item 3 because in transaction 2, we have item 2, item 3, and item 4. So since item 3 was already linked to item 2, which was already linked to root, then it means we can just link item 4 to item 3 because they're in the same transaction. Yes, so what we are actually trying to say is that, see, we have root here, root. Item 2 ishachukua mkondo yake because of the maximum. And by the way, we still do not know if it is 5, but let's just work with it the way it is. Then 2 items were linked because they were in transaction 1, item 3 and item 2. Item 1 and item 2. Item 3, sorry, item 1 and item 3. Sorry, thank you. After linking, you also look at item 3 in transaction 2. In transaction 2, what were contained in transaction 2? We have item 1, item 2, item 3, item 4. But since item 2 has been linked to root, there is no problem. Item 3 has been linked to item 2. So item 4, because they're in the same transaction T2, must be linked to item 3. Yes, all of them actually goes back to root, but there's that guy who does the linking to root. Yes. Aya. Then we continue. Then in transaction 3, item 4, item 5, similarly, a new branch with item 5 is linked to item 4 as the child is created. Transaction 3, sinamaanisha hii na link item 5. Tulikuwa hapo kwa transaction 1 bado. In transaction 4, we add item 1, item 2, item 4. The sequence will be item 2, item 1, and item 4. Item 2 is already linked to root node. Hence, it will be incremented by 1. So that's why unaona nimeanza bado sija increment kitu. As it is being incremented from the database, we just keep it that way. So let's do the linking first. Similarly, item 1 will be incremented by 1 as it is already linked to item 2 in transaction 1. Thus, item 2 becomes 3, item 1, 2, and item 4, 1. Now in transaction 5, so there is nothing linking there, just incrementing. Transaction 5, in transaction 4, we are not linking because all of what are contained in the database have already been linked. The only thing we do is now incrementing. Are we together? In transaction 5, we have item 2, item 1, item 2, item 3, item 4. The sequence will be item 2, item 1, item 3, and item 5. Thus, item 2 in incremented, same to item 1 and item 3. And now item 5 now becomes 1. In transaction 6, the same thing. Thus, item 2 becomes 5. That's now when we go back and put 5. And item 1 becomes 4. And item 3 becomes 3. So we go back to item 3. We put 3. Are you able to hear me? Oh. And item 4 remember we are basing our argument item 3 3, item 1 4. There's something I'm missing here. When did we, there's a step we missed. There was a place where item 3 was being linked to item 1 here, where item 3 was being linked to item 1. Was it in transaction 1? Yeah, transaction 1. Transaction 1. I1 is linked to I2 and I3 is linked to I1. So in transaction 1 here, because remember this one was one transaction. Other in short, we are forming transaction in form of a tree. So the transactions must be actually realized from a tree. So I2, I1, I3, this is transaction 1. Then transaction 2 contained I2, I3, I4. So we must also realize that that one works. I2, I3, I4. Then transaction 3, I4, I5. Meaning transaction 3 did not originate from I2. So meaning it is a standalone. That's why we branch it I4, then I5. So this is transaction 3. Then transaction 4, I1, I2, I3, I5. That's when we did the branching. I1, I1, I2. Hmm? Uh, okay. See, this is transaction 3. So we are now under transaction 5. Right? Transaction 4. I2, I1, I2, I4. Okay. I1, I2, I4. Hey, realizing that transaction, how was it captured here? I3, I4, I2, I3, I4. Yeah, and that's the reason why for number 4 has just one. Oh, it was removed. Wait, which one was removed? There was one that was removed. We said I5, transaction I5, count of each item. So delete the item that fails to meet. So anything that has transaction I5 was removed. So meaning transaction 5 was the one removed. So transaction 4 should be there. Transaction 3 exists here. That one has been well. Yeah. Remember, we are removing based on an item that fails to meet minimum support threshold. So item 5 was the one that was removed. So meaning if it was removed, then why is it making it to the database? May I kindly go and do more research on this before I continue. The lowest node, item 5, is not considered as does not have minimum support, hence it is deleted. The next lower node is what, I4. Now let me go and do more results, research on this. So by Monday, I'll be at a better place to explain it. So as you can see, it is complex, and I think that is one of the if it is more cumbersome and difficult to build an a priori, it may be expensive, and when the database is large, the algorithm may not fit in the shared memory. That I think we've been thinking about that. So let's Let's conclude at that point. Then we shall continue with nini. Okay, tushafika hapa. My friend, this is one of my favorite. Yeah, because when I teach it, students almost run out of class because they're like, wait, so we've reached, okay, we are within the nini. We've reached recommendation system. Once we're done with recommendation system, they're in a queue. Then we are going to deep learning. Course is just almost. Okay, we can stop at that point and meet tomorrow. So I'm going to do more research on FP growth, then come back with solid explanation on Monday.